All right, so we're going to move on to our next sort of segment of logic, and we'll look at conditional reasoning today. So conditional reasoning, we tend to see conditional reasoning when we see if-then statements, but also we can see them with only and unless. So let's take a look at a few examples. If the snow continues until 8 p.m., the flight will be canceled. So that's our first statement, our major premise. And then our next premise, we have it is 8:10 and still snowing. Therefore, the flight is canceled, right? So you can see how the flight is canceled follows from that argument. All right, let's look at another one. If the surgery is a success, then she will run the marathon in the fall. She did not run the marathon in the fall, so the surgery was not a success. Now we can ask, is that one a valid argument? We know if the surgery is a success, then she will run the marathon. She did not run the marathon, so the surgery was not a success. So that's a valid argument. All right, let's take a look at this one. Unless you pay the mortgage, the house will be foreclosed on. The house was not foreclosed on. Therefore, you must have paid the mortgage. So we use unless there, same sort of framework. But you notice that the statement is flipped, right? So if you want to render this in an if-then statement, you would say, if the house is not foreclosed on, then you paid the mortgage, right? So we have did not pay the mortgage. Excuse me, the house was not foreclosed on, therefore you must have paid the mortgage. Right, and then finally, I will only go to the party if Carla is not there. I decided to go to the party, therefore Carla was not there. So let's take a look at this. So this is valid, right? That conclusion follows. But what if we said Carla was not there instead? So I will not go to the party if Carla, I will only go to the party if Carla is not there. Carla is not there. Can we say, therefore, I will go to the party? So that does not quite follow. I will and only will go. If we would have said it that way, then the conclusion would have followed. All right, so conditional arguments. Let's take a look at these. I will go to the party if Carla is not there. Carla is not there, so I went to the party. So in this one, right, similar to the last one, but I will go, right? So if Carla is not there, that means I'm going to go to the party. So I will go to the party if Carla is not there. Carla is not there, therefore I went to the party. I will go to the party if Carla is not there. I went to the party. Carla was not there. So in this one, notice it says I will go to the party if Carla is not there. So if Carla is not there, then I will go to the party. Notice that it doesn't say if and only if Carla is not there, I will go to the party. So that argument is not valid because we can't draw that conclusion from the second premise. All right, so in here I have a note on that. Consider what you'd mean by the sentence, I will go to the party if Carla is not there. So the way I rendered it, right, if Carla is not there, then I will go to the party. That changes the way or the validity of the sentence. If I say if and only if, I will go to the party if and only if Carla is not there. Then the conclusion follows from it, right? It's a valid argument. How do we take these things, right? We sort of saw how this statement, I will go to the party if Carla is not there, can change depending on how we translate it. So let's take a look at it this way, right? This is what I said before. If Carla is not at the party, then I will go to the party, right? So we just take that if clause, put it at the beginning, and then take the first part of the statement and put it at the end, following that. So then we have a standard if-then statement. We could say, if I go to the party, then Carla was not there, right? If that's the case, right, then our statement before on the previous page, right, is going to be true, is going to be, or is going to follow, excuse me, it'll be a valid argument. But what this is saying is if I'm at the party, Carla is not there, right? So the only chance for me being at the party is if Carla is not there. We could add both, right? Put both together, and then we have a biconditional. So that's when I said if and only if, right? I will go to the party if and only if Carla is not there. Okay. So conditional reasoning. So generally what we have is a one-way street, right? So it's the if-then statement. So if you're late for the appointment, then they will not see you. Your appointment was at 8 a.m., excuse me, and you did not show up till 8:20. Therefore, they will not see you. So the direction there is only in one direction. If you are late for your appointment, then they will not see you. Biconditional statements, right, let you go in both directions. So if the first part is affirmed, then the second part isn't true. And if the second part is affirmed, then the first part is going to be true. If you negate one side, then the other side is negated, right? So the garbage will be picked up every Thursday. The garbage was picked up today, or you could say it is Thursday. The garbage will be picked up if and only if it's Thursday. That's another way of putting this. It is Thursday, therefore the garbage was picked up, right? So the garbage will be picked up if and only if it is Thursday. You could say the garbage is picked up, therefore it's Thursday, or you can say it is Thursday, therefore the garbage is picked up, right? Either direction works. So that's biconditional reasoning. So these statements that I've been using, those if statements, they provide us with a certain kind of way of thinking about the conclusions that we're getting. So necessary conditions means that whatever the conclusion needs to have that as a premise for it to be true. Sufficient conditions is if you have that premise, then the conclusion is true, right? So the watering of the plants is a necessary condition for the plants being alive. So if the plants are alive, then they have been watered, right? So the watering the plants, right? That watering must be true for the plants to be alive. If and only if statements. So having hair is both a necessary and sufficient condition for being a mammal, right? What does that mean? That means if you're a mammal, then you have hair. That means if you have hair, that you're a mammal. So being a mammal is both a necessary and a sufficient condition for having hair, right? So hopefully you can see the difference there. So let's take a look at this, this first statement here. If I go to the party, then Carla won't be there. So let's look and see what possibilities we have. So if I go to the party, Carla won't be there. I went to the party, therefore Carla wasn't there. It's a valid argument. So I affirm the first part, then the second part is true. If I go to the party, then Carla won't be there. Carla was not, or excuse me, Carla was at the party, right? What does that mean? It's not the case that Carla was not at the party. So I'm negating the second part. Therefore, I did not go to the party. That also is valid. So if you negate the second part, our conclusion is a negation of the first. Okay, now what about these second two? If I go to the party, Carla won't be there. Carla was not at the party, therefore, I went to the party. So what I'm doing there is I am affirming, right, the second part, but the second part is just a necessary condition, but not sufficient, right? So it doesn't give us the conclusion. Therefore, I went to the party. So it doesn't get us all the way there. Same thing with this last one. If I go to the party, Carla won't be there. I did not go to the party. Therefore, Carla was there, excuse me. So not going to the party doesn't mean that Carla won't be there, right? Because I can not go to the party for all sorts of reasons. Not just if Carla is not there. Okay, so that's invalid too. So if and only if Carla is not at the party, then I will be at the party, right? So if the first part is affirmed, if Carla is not at the party, then I will be there, right? Or if I'm at the party, then Carla is not there, right? So you can take it, you can start with either statement, and then you get as a conclusion the other statement. So this brings us to our four types of arguments. Two of those are going to be valid, and two of them will be invalid. So modus ponens, which is affirming the antecedent. Antecedent just means the first part. So if A, then B, A, therefore B. You can only have dessert if you finish your carrots. You finish the carrots, therefore you can have dessert. So the if statement is the second part of that statement, actually. So if you have carrots, or excuse me, if you finish your carrots, so it's the A, then you can have dessert. You finish the carrots, right? Then you can have dessert. So that's a valid argument. How about this one? If the maple leaves are red, then it is autumn. It is not autumn. Therefore, the maple leaves are not red. So we can deny the second part, right? It is not autumn. And we can conclude the negation of the first part. The maple leaves are not red. So both of those are valid. So let's look at our two invalid versions. If the maple leaves are red, then it is autumn. The maple leaves are not red. Therefore, it is autumn. And we know this is not true, right? The conclusion. And what's wrong with this? Right. So what we've done is we've negated. We said no to the first part. So it's not the case that the maple leaves are red. Then, right? Then what? It still could be autumn. It could be the beginning of autumn. Right? It could be late autumn. They're all brown. Right? So it doesn't tell us anything about the conclusion. And finally, if the maple leaves are red, then it is autumn. It is autumn. Therefore, the maple leaves are red. So here we're affirming the second part, the B. And by affirming the B, we don't get to the A. So again, it can be autumn, but maple leaves might not be red, right? They might be green still, or they might be brown, right? Maybe they're yellow. So we don't get that conclusion. So for biconditionals, the statement's always, the conclusion's always going to follow if we say either side, right? So if that is a flying mammal, then it's a bat. If that is a bat, then it is a flying mammal. So if and only if it is a flying mammal, then it is a bat, right? So if A, then B, if B, then A. If and only if A, therefore B. If and only if B, therefore A. So they're the same statement, either direction. So here we can see that either way, it's going to be true. So if and only if it's a flying mammal, then it is a bat. So it is a flying mammal, therefore it's a bat. It is a bat, therefore it's a flying mammal. It's not a flying mammal, therefore it's not a bat. It's not a bat, therefore it's not a flying mammal. All right, so we've taken a look at a few types of arguments now. Remember that deductive arguments are either valid or invalid. If they're valid, they can be sound or unsound. That just means that if they're unsound, that just means that the premises aren't true. Or if they're invalid, they're necessarily going to be unsound. So next we're going to look at categorical arguments.